So we're continuing to talk about domain and range. We're going to spend one more day on this tomorrow, and then Friday you guys have a quiz on 6.1 to 6.3. So everything we learned about relations so far, which is, remember, being able to determine whether a relation is linear or not, and we went through all the different ways you can do that depending on what you're given. If you're given a table of values or a set of ordered pair, I showed you how you can determine whether that is linear or nonlinear. If you have a graph, it's pretty simple. You can look at it and see if it's linear or nonlinear. But we also talked about what you do if you have an equation. From an equation, how do you know whether it's linear or nonlinear? So we looked at all those things. We talked about whether data is discrete or continuous. We talked about independent and dependent variables. So those are all the things that we talked about in those first two sections. And now we're talking about domain and range. So the domain are all the independent variables. When you have a table of values like this first example, the domain will just be the x values. And when you're given a set of ordered pair like this is an example of discrete data. Only those points are part of the relation. You cannot assume that the values in between these points are part of the relation. So when we set or state the domain, it will be a list. So that would be one way to state the domain, as a list. Right? You cannot use interval notation though, because if you use interval notation, which goes from the smallest value to the largest value, when you use interval notation, you're saying it's real numbers, and it's not. It's only those specific values. And because they are consecutive integers, we could use set notation here, all values of x, such that x is greater than or equal to -3, less than or equal to +3. But in this case, those are all integers. So x is an element of integers. So you'd have those options for the domain. Because they are consecutive integers, you can use set notation. The range are just the y values, or the second set of numbers from the ordered pair. The numbers 9, 4, 1, 0. Now we already have stated 1 once. We don't have to state it again. You could, but you don't have to. We've got a y value of 2, which we have to state, and then finally a y value of 9, which we have at the start, so you don't have to state it again. If you write the 2 twice and the 9 twice, it's not wrong, it's just not necessary. And in this case, because it's not consecutive integers, you cannot use set notation. The only way you can express the range of this would be a list. So number 2, also, that is discrete data. Those points are part of the relation. You have nothing telling us that points in between are also part of the relation. So it's discrete data. Cannot use interval notation. For the domain, we just have to state the x values. And because they're not consecutive integers, you cannot use set notation. You can only use a list. Same thing with the range. You just state the y values. And it doesn't matter what order they're written in. If you wanted to rearrange them from smallest to greatest, that's fine. It doesn't matter what order they are written in, as long as you state all the values. So this next one, we haven't looked at this before. This is called a mapping notation. It shows how items in one set are connected to items in another. From this mapping notation, we can create a table of values. The values in the first set, in that first circle, if you want to call it that, are the x values, or the independent variable. And the -2 is connected to the +2. So that's that ordered pair. The -1 is connected to the +1. That's that ordered pair. The 0 is connected to the 0. The 1 is connected to the 1. And the 2 is connected to the 2. Now you don't need to do this part because the domain will just be the numbers in that first set, which again, we have options here. We could use a list. Or because they are consecutive integers, we could also use set notation. We just have to say that x is an element of integers. Because they are consecutive integers, you can do this. The range are just the y values. There's only 3 of them, 0, 1, and 2. But once again, because they are consecutive integers, you could use set notation. You just have to remember that for the range, the variable used is the letter y. So this is the 3rd time in a row you've been late?
3rd.
Yep. So the next time, there's going to be issues. Okay? Did you guys sign in downstairs? So because they are consecutive integers, whoops, that's wrong. I got to put I in there, not real numbers. You can use set notation. Because they are consecutive integers, you have to say that y is an element of real numbers. So from a graph, we want to state the domain and the range. So this graph, again, is discrete values. Only these points are part of the relation. So for the domain, it's the x values. Now we have 2 points that share an x value of -2. You don't have to write -2 down twice, so once is fine. We've got an x value of -1. That's that point right there. We have a couple x values of 0, but again, you only have to write one of them down. Then we have +1, and then it skips to +4. That's the domain. And because they're not consecutive integers, right, the first 4 follow a pattern of consecutive integers, but the last one doesn't. So we cannot use set notation for the domain. We can only do it as a list. Again, this is discrete data. For the range, our smallest y value actually is -5. And then -3, and then 0, and then +3. Again, it's not consecutive integers, so you cannot use set notation for that one. The only option is just a list. Number 5, we've got a graph of a line that goes upwards to the left, princess, and downwards to the right. As you go upwards, you're going to the left forever. This graph goes from -infinity to +infinity along the x-axis. So the easiest way to do this would be interval notation. Remember, it's always smallest to greatest. And you must use rounded brackets here because those n values cannot be included. You cannot define what infinity is. And the range is exactly the same. It goes downwards and upwards forever. You could also use set notation here. All values of x such that x is an element of real numbers. That means all numbers, all positive, all negative, all fraction, all decimal. Same thing with the range, only you're changing the variable to the letter y instead. So that also means all real numbers. It also means from -infinity to +infinity. Okay? So number 6 is also a line, but it's going to be a little bit different. This graph does go to the left and to the right forever. So the domain, we could say, is from -infinity to +infinity, or using set notation, all values of x such that x is an element of reals. But that's not the same for the range. Because this is a horizontal line, there's only one y value on this graph, and that is that y equals +4. That's the only y value that belongs to this relation. No matter where you go on the graph, the x value will change, but the y value won't. So our range is just the number 4. No matter where you go in this graph, the x values will change, but the y values are constantly 4. Number 7, as this graph goes downwards, it's going to the left forever. And as it goes downwards to the right, it's doing that forever as well. This graph goes left and right forever. The domain is all real numbers, or from negative infinity to positive infinity. But that's not true of the range. This graph goes downwards forever, but it doesn't go upwards forever. It only goes up to this point right here where y is positive 5. So if you're going to use interval notation, remember you always go from smallest to greatest? This goes from negative infinity up to positive 5. The 5 is included, the negative infinity is not. If we use set notation, all values of y such that y is less than or equal to 5. And again, y belongs to the set of real numbers. All fractions, all decimals less than or equal to 5, as well as integers, are part of this relation. That's what real numbers tells us. Question 8. As this graph goes upwards, it's going to the right forever. As it goes downwards, it's going to the right forever. This graph goes to the right forever, but it doesn't go to the left forever. It starts right there, where x is negative 1. So if we're going to use interval notation, we'll go from negative 1, which is included, up to positive infinity, which is not. Or if we use set notation, all values of x such that x is greater than or equal to negative 1. And it's all real numbers. This is continuous data because all the points are joined with that curve. The range, though, will be all real numbers. This graph goes upwards and downwards forever. As it goes to the right here, for the top part, it's going in that direction forever. It's going upwards and to the right forever. And it's going downwards and to the right forever. So this graph goes up and down forever, so the range goes from negative infinity to positive infinity. Or if we wanted to state it in set notation, it would look like that. Okay? Try number 9 on your own and then we'll check it. You can do this one with both interval and set notation. You don't have to do both. You could also use words like we looked at yesterday, but I just wouldn't recommend it. It takes much longer. What do you think the domain is, Ali? Except that you got to go from smallest to greatest. Yep. Is the 1 included or not? And how do we show that? Square bracket. Is the infinity included? So that's a round bracket. So using interval notation, it would look like that. Set notation, x is greater than or equal to 1, and x is an element of real numbers. What'd you say the range was, Keen? Can you help him, Declan? Like that? Is he right, John? Why not? Yes, the infinity is definitely negative, and so that has to come first. It's always smallest to greatest. And if we use set notation, all values of y such that we could just say y is less than or equal to negative 3. Okay, try number 10 on your own. And if Keen gets this one right, we'll all clap for him. What do you say, Keen? What's the domain? Okay. You just take your sweet time. You ready? You give up? So I guess we're not going to clap for you. What do you think, Emery? Domain. What do you think the domain is? Sorry, can't hear you. Negative 1? What shape would the brackets be? Square or rounded? Is that right, Sophia? Calling her a liar? Sounds like it to me. You guys going to fight after school now? Okay, my money's on Sophia. She's an athlete. What's wrong with it? Yeah. Because if you look where x is starting, it starts at negative 2 and it goes to the right as far as positive 4. You see that, Emery? So what do you think the range is then? This is your chance to redeem yourself. You're good? Okay. Peyton, what's the range? Like that? Like that. Can bet a pop on that? Is he right, Cherry? Why not? It's actually negative 5 to 1. He's got it backwards. Remember, you always got to go from smallest to greatest. Always. Oh, that's so sweet, Brock. That's so sweet. I'm just saying, that's sweet. Some people high five, some people kiss when they get it right. That's whatever works, works. Always go from smallest to greatest, right? So we got to fix that one. From negative 5 to positive 1. Now, both of these can be done using set notation. So let's do the range first. We would say that y is greater than or equal to negative 5, less than or equal to 1, and y is an element of real numbers. So for sure, interval notation is a much easier way to do it, but some people prefer set notation. The domain will be that x is greater than or equal to negative 2, less than or equal to 4, and x is an element of reals. Remember, whenever you use interval notation, which is the brackets one, you're saying it's real numbers. You cannot use infer notation if the data is discrete. But this is continuous data because all the points are joined together and it forms that circular shape. Okay, so do number 11 on your own. And if Brooklyn gets this right, we'll clap for her. Keen already had a chance for us all to clap for him. Oh, yes, I think you do. It'll be good for your self-esteem. What do you think the domain is, Brooklyn? Up to? So -7 to 1. What shape would the brackets be? Square on both of them? Rounded on the 1? Don't look at Keen. Yeah, what? Rounded on the 1? Is that right, Ava? Why not? Yes, the 1 is included, so that would be a square bracket. Okay, that's that point right there. Okay. If we use set notation, Keen just had an epiphany, I think. Emil, what about the range? What shape are the brackets? Is that right, Keen, for the range? The range is the second part of this question. We've got the domain, now we want to state the range. Emil said the range was from -1 to 5 with square brackets. Is that right? So the range are the y values. Does it go up? Does it go down? How far? The lowest point on the graph corresponds to this line right here where y is -1. The highest point on the graph corresponds to that point right there where y is +5. So it goes between -1 and +5. So that is correct. So using set notation, you might need a little bit of professional help there, Keen. Which is available downstairs, free of charge. Okay? All right. This assignment is due for marks. So those 2 pages. So we're talking page 41 and 42. Just that page, rip it out, put your name on it. When you're done, you hand it in on the filing cabinet there. It counts for marks. So for question 1, you can only use a list if it's discrete data. If it's continuous data, you cannot use a list. So for that very first one, you're given the relation in words. It says all real numbers less than 5. You cannot use a list for that because all real numbers refers to all fractions, all decimals, as well as all integers less than 5. And you can't state them all. It's impossible to state every decimal less than 5. So you cannot use a list if the data is continuous. So that's the same thing with interval notation. The second row, that's interval notation. As soon as you see interval notation, that means it is continuous data. So you cannot use a list for that either. The third one is the same. It says X is an element of real numbers. You cannot use a list for that because real numbers, again, tells us that it is continuous data. You can only use a list with discrete data. Okay? So, again, make sure you put your name on it. Don't forget to do that. And this one is going to be collected for marks. We'll spend one more day tomorrow talking more about domain and range. Maybe Keen will be saying less and less tomorrow, hopefully. And then we're going to have a quiz including this stuff on Friday. Okay? What's all the sign about? Yeah, make sure you sign out. One o'clock.
You did not send it. You sent it to the wrong person. No, you accepted it. Okay, fine.
Thank you.
Send it.